Okay, guys, can you all see my screen before we start? Yes, no. Can you even hear me?
Yes, we can see the screen.
I can see the screen and I can hear you.
Thank you.
Just to, did you say it might be on the 23rd of November?
Yes,
Okay,
23rd of November. But it can still change. They can move it closer or later. But for now, it says the 23rd of November.
Okay, thank you so much.
Okay. I think we should start on from the exercises I gave you guys yesterday. Do you remember this question? This one. I don't remember other ones. Okay. We were given Cx as 1/5 x to the power 10 minus 2 x to the power 4 plus 5/2 x cubed. We will need to Mike. Please mute.
뭐라고 먹어?
Okay, we were asked to find the first derivative up to the fifth derivative. Okay, given that Cx. Did you guys try? Yes, no? I've set the exam already, and if you guys don't do the exercises that I give you, you will be forced to do them sometime, maybe in the exam, I don't know. Yeah. Okay. We have this as C at X. And then first we need to find the first derivative. And then we need to differentiate C at X with respect to X. And this is C prime, right? Okay. If we do this, if you differentiate this, you see, for other terms, we need to apply the power rule. But for other terms, we need to apply chain rule, right? Okay. For your first derivative, you should have 2 Why is it not writing? Should have 2 x to the power 9 minus 8 x cubed plus 15 over 2 x squared plus 1 over 2 x to the power minus a half plus 3e 3x plus, okay, that is 1 over 2 squared times 2 times 2 over x. Okay, you can change this and so that it will have a positive exponent. Did we all get this as our first derivative?
Hello.
Yes.
That last part, I know ln x is usually 1 over x, if I'm correct. So the exponent of the x in brackets, is that going to be what's on top of the x if you derive it?
We have, I will name this f(x). Okay. My pen is not writing and I've just changed my batteries. I'll let ln x squared to be f(x). And we want to find the derivative of f(x), right? You see here, this function, the original function of this one is it's supposed to be ln x, right? If this function was ln x, then our derivative was going to be 1 over x, right? But instead of x, we have a function inside, which is x squared. We don't have just x, right? Meaning we have a function, an inside function and the outside function, right? Remember, if we have something like this, you let the inner function to be u, you let the outside function to be v, right? And according to the chain rule, oh God, and according to the chain rule, the derivative of the chain rule would say, okay, I'll say this is the inner function and this is the outer function. The outer function is v and the inner function is u, right? It means the chain rule would say the derivative of this function would be the derivative of v times the derivative of u, right? V is 1 over u because we said this is u, right? So okay, v is ln u and the derivative of ln u is 1 over u, right? Times the derivative of u. U is x squared. The derivative of x squared is 2x, right? Then the next step is to substitute u back. We said u is x squared, right? So we have 1 over x squared times 2x. We have x over x. 1x here will cancel up with this one, and we'll be left with 2 over x. That's why here we have 2 over x. Is it fine?
Yes, thank you. I'm just writing it down.
Can we continue?
Yes, and ma'am, you said it's the product rule, right?
Well, here. No, it's not the product rule, it's the chain rule.
Chain rule. Thank you.
Okay, can we move on?
Yes, please.
Okay. We now have the first derivative. We need to find the second derivative. To find the second derivative, we need to differentiate the first derivative, right? So we write our second derivative as dc prime with respect to x. Okay, this part, it's either I write this part as d squared c over d x squared. This is the same thing. It means the same thing. Here it means we differentiate c twice. But we've already, we know the first derivative, we've differentiated once already. So there's no need to repeat differentiating. Or there's no need to find the first derivative again. We can just differentiate the first derivative to get the second derivative, right? Okay, now I will differentiate this function, right? And if I differentiate this function, I should find 18x to the power 8 minus 24x squared plus 15x minus x to the power minus 3 over 2 plus 9e 3x minus 2x minus 2. Okay, did we find the same thing for a second derivative? Did you get the same thing? This function?
Yes,
Okay.
yes, we did.
Yes. Okay. Thank you. Then the next step is to differentiate this function to get the third derivative. Okay, I'm not going to find the third derivative, the fourth derivative, because now it's easy. You're just going to apply the power rule only in all the things. Okay, this is part of the chain rule. But from here, it is easy because you just apply the same rule until you get the fifth derivative. Okay, can we move on to today's session? Yeah. Okay. Today's session is optimization of function in one variable. Right. Remember, I said the aim of this module is to learn to maximize the profit, maximize the revenue. Okay, maximizing the revenue will maximize the profit, and to minimize the total cost, right? Okay. And that's the reason why we need to study optimization, because optimization is just the process of finding the maximum and the minimum point. Né? So this section will help us find the points whereby the profit is at maximum, like the points that will give us the maximum profits. Like it will tell you, it will help you understand or find how many products that you need to sell for you to find the maximum profit, and how, like, it will tell you or make you understand how to find the number of units of the products, like the minimum products that you need to sell for you to find the minimum profit. And like the maximum products that you need to sell for you to find a negative product and a negative profit. I know no one wants to find negative profits, because that's like it's a cost, it's costing your business, right? It means your business is not doing well. So this section will help you find the points of the quantity that you need to sell, like say per day, per month, per week, for your business to make profits. Okay, optimization. We said optimization is just the process of finding the minimum and the maximum point, right? Okay. The maximum and the minimum point, those are points. They are sometimes called the stationary points, right? Okay. Suppose you are given a curve. Let's say we are given this curve. This function represented by this curve. Okay, now the stationary points, these are just the points whereby the curve is changing from negative to positive or from positive to negative. You see here, our function is increasing, right? Because remember, here we have 0 at the origin, and the numbers are increasing from this side to this side, right? And then from this side to this side, the numbers are decreasing, right? So it means if the graph is moving from this side to this side, it's increasing. So it's positive. Okay, I'll say we have positive here. And if the graph is moving from this side to this side, we say the slope is negative. And if the graph is moving from here to here, then we say the slope is negative, right? So the stationary points are the points whereby your function, any given function or any given curve is changing its slope from, it's either from positive to negative. You see here, it's positive until here. Then now from here it's negative. So it means in this side we have this point as a stationary point. Again, we said this part is positive, right? And this part is negative. So this means this point whereby our graph is moving from negative to positive, we call this point the stationary point. Okay. The stationary point whereby the graph is moving from positive to negative, it's called the maximum point. And the stationary point whereby the graph is moving from negative to positive is called the minimum point. Okay. Remember, I said when the graph is increasing, we say the slope is positive. Okay, the slope. And at the next, on the stationary points, the slope will always be 0. So which means here the slope is 0 and here the slope is 0, right? And from negative, okay, from when the graph is negative, is decreasing, we say the slope is negative. And when the graph is increasing, we say the slope, okay, the slope here, because the graph is moving from the stationary point, and this stationary point is whereby the graph is moving from negative to positive. We say here the slope is positive, right? In maths, in maths, a slope is defined as the derivative, right? So instead of writing the slope, because we said the slope is equal to the derivative, meaning the first derivative. Okay. If this curve represent the function f at x, the slope of this curve will equal to f prime at x. Again, remember f prime at x is equal to the derivative of f with respect to x, right? Okay, remember I said here from this side, from this side to here, the slope is positive again. Then here at the top, the maximum point, whereby the slope changes from positive to negative, then the slope will always be 0 on the stationary points. And again, here, the slope is moving from negative to positive. Again, here, on this point, the slope is 0. Okay, and we said the slope is equal to the first derivative, meaning the slope is equal to df over dx, right? You see, we can use this information to find these points, which are called the stationary points, which are called the maximum or minimum point, right? Because we know that here on this function, the slope is equal to 0, right? Are we all still together?
Yes, ma'am, we are here.
And yeah, these are called the stationary point, or sometimes they are called the turning point, because you see the slope is turning from positive to negative, and it's turning from negative to positive. So these 2 points, they are called the turning points. Okay, you can sometimes you will be given a function with more than 2 turning points, sometimes with just 1 turning point. But to find those turning points, you will use the same method, which is the first derivative is equal to 0. Okay. To find the turning point, you follow these 3 points. Okay. Turning point. You will first find f prime at x. And then you let f prime at x equals to 0. And then you solve for x. Okay, because this function is in terms of x. To differentiate between this x and the one that you are solving for here, you can just let this one to be s star, x star, and you know that this x star represents your turning points, right? Then the next step is to find the corresponding value of x. Remember, if we find x, only the value of x, that means we know what is x here, this value, but we don't know this value. For this to be a point, it must have the x value and the y value, right? To get the y value, you will take this x and substitute back to your f at x. Make sure you don't substitute here on f prime at x. You need to substitute it on your original function, which is f. Okay. After substituting here, you will find, you will have x dots and f x dots. This is your turning point. It's either the minimum point or the maximum point. Right. Okay. If you are told to find the stationary points, you will do only these 3 steps, right? But remember, I said your stationary points can either be negative or positive, right? If you are asked to find the nature of the stationary point, that means you are asked to determine whether the point is a minimum point or a maximum point, right? This is how you will find the nature of the turning point. Okay, to find the nature of the turning point, you need to determine the second derivative. You need to find the second derivative. We have the first derivative. You need to differentiate this derivative, the first derivative. Okay, you need to differentiate this derivative to find the second derivative. You see, why did we study the higher order derivative? This is the reason why. Because the first derivative doesn't capture any information about the nature of the point. Remember, I said the reason we need to study higher order derivative is because sometimes first derivative doesn't capture other information about any given model. Okay, you see, this is one of the information the first derivative doesn't capture, which is the nature of the points. Okay, I said to find the nature of the points. Okay, I'll just say TP. You need to determine the second derivative of your x star. Remember, we are finding the nature of the turning point of the stationary point, and we said we will use x star to denote the turning point or the stationary point. Okay, we have, after finding, okay, remember the reason you need to find the second derivative is because you want to determine whether the point is the minimum point or it's the maximum point. Remember, the second derivative is equal to df with respect to x. Now, if your second derivative after substituting x star is less than 0, then this means this point is the maximum point. And if the second derivative is greater than 0, this means this is your minimum point. Okay, please do not confuse these two. If second derivative is less than 0, then you will find the maximum point, right? And if the second derivative is greater than 0, then you will find the minimum point. Okay. This is how I always remember these two. Okay, suppose you have something like this. Suppose you are throwing a ball from here to this part. Let's say this is just the boundary thing. If you are throwing the ball from here to here, you'll see it will reach the maximum and then come down, right? And if you are throwing a ball from here, from up to bottom, it will reach the minimum and then it will come up, right? You are up, you are throwing it down, it will reach the minimum and then it will go up. Meaning these parts, just take this as in, okay, you are here at the top, this is greater, that right, it's greater than 0. You are throwing it down, then it's reached the minimum, then it's go up, meaning you will find the minimum point. Now, suppose you are below 0, meaning you are less than 0. You throw a ball up, it will reach the maximum, and then it goes down, meaning you'll find the maximum point. Is it fine? Can we do an example?
Yes, please.
Yes,
Let's do an example.
Okay. Okay. Let's say we are given f(x) equals 200 minus 2 times x minus 4 all squared, right? Let's say the question says, find the turning point and the nature of the turning point, right? Remember, I said to find the turning point, you have to follow 3 steps. You find the derivative, you equate the derivative to 0, and then you will take the x that you'll obtain after equating the derivative to 0, and then you'll take that point, that x, you'll substitute it back to your original equation to find the corresponding point. Right, okay? First part is to find the derivative of the function, of the given function. This is our function. This means we need to find f prime at x, right? Okay, our derivative would be, we'll have minus 4 times x minus 4, right? Because we have, okay, I'll say this is our, okay, first here, this is a constant. We know that the derivative of a constant is 0, right? So this means we have these parts, right? Okay, I will take these parts as the inner function and take these parts as the outer function. So this means we have, okay, I'll say g at minus 2 into x minus 4 squared, right? If I let this to be u, we have u equals x minus 4. I let v to be minus 2v squared, right? And then if we apply chain rule here, we'll have g at x equals v prime times u prime. The derivative of v prime, we have minus 2v squared, right? It will give us minus 4 minus, okay, this is u, minus 4u, right? Times the derivative of this, of u with respect to x is 1, because the derivative of x is 1, the derivative of minus 4 is 0. So this means we have minus 4u, and we know that u is x minus 4. Then you substitute back your u here. This means the derivative here would be minus 4x, minus 4 into x minus 4, right? That's why I said our f prime is minus 4 into x minus 4, right? Okay. Then the next step is to let your derivative to be equal to 0, right? Okay, we let f prime at x equals to 0. And we know that our f prime is minus 4 into x minus 4 equals to 0, right? Then I said after equating your derivative to 0, you can let your x be x star. Because yes, this is the reason I said you let your x to be x stars, because I don't want you to confuse that x with this x, with the given initial x, right? Okay, we'll say minus 4 into x star minus 4. And besides, I said we'll use x star to represent the stationary point, and here we are trying to find the stationary point. Okay, and if you solve this, you will have Okay, this means it's either this equal to 0 or this is equal to 0. Because remember, if you are multiplying if you are multiplying two terms and you are told that the multiplication equals to 0, that means one of those two terms they are equal to 0. And we know that -4 does not equal to 0. -4 does not equal to 0. That means this is equal to 0. So this means we have x star -4 equal to 0. And if you solve for x here, you have x star, you transpose -4 to this side, and it will change sign. So we have x star is equal to 4. Right. And this is our x value of the stationary point. Right. And remember, I said the next step after finding the x value of the stationary point is to take that x value and substitute it back to your original equation, your original function, so that you find the corresponding value of x star. Okay. Our f at x original function is this. We need to substitute x star there to find f at x star. Okay, we know that f at x is equal to 200 minus 2 times x minus 4 all squared. Right. So if we substitute here, we will have, okay, our x star is 4. We are substituting x star here, meaning where there is x, we substitute x with 4. Right. Okay, this means we will have 200 minus 2 into 4 minus 4 all squared. Okay, this gives us 0. 0 times 2 is 0. So this means our f at x star is equal to 200. This means our stationary point is 4 is to 200. Right. Remember, the question didn't just say we should find the turning point only. They said we need to find the nature of the turning point too, right? And to determine the nature of the turning point, we said we have to find the second derivative of the given function, right? And if the second derivative of that function is less than 0, then we'll say the turning point is the maximum turning point. And if it's greater than 0, then that turning point or that stationary point is the minimum point. Right. Okay, we said our f prime is -4 into x minus 4. Okay, f prime is -4 into x minus 4. And we need to find f prime prime. To find f prime prime, we said we differentiate f prime. Okay, with respect to 0. If we differentiate this f prime, we will find -4, right? Okay, and you see this, okay, and you see f prime prime is less than 0, right? So this means 4 is to 200 is a maximum point. Is a maximum turning point. Okay, sometimes you'll find your derivative, your second derivative as a function. Let's say if we were differentiating the first derivative, we find something like this. Let's say we obtain 4x plus 3, right? The next step was to substitute your x star. Our x star is 4, right? So the next point was to substitute here where there is x. And if you substitute here where there is x and this is greater than 0, then you say this is the minimum point. But if you substitute here the value of x and this gives you negative, then that point was going to be the maximum point. Okay, my point is the second derivative will not always be a constant. Sometimes it would be a function. Then after finding that, you substitute the x value. That's the x value of the turning point that you want to check its nature. Okay. In your spare time, please work on this one. F of x equals 64x plus 1 over x. Okay, do we have questions? Are we all still together?
Sorry, ma'am.
Yeah.
Can you please go back a little bit? I got lost there. How did you move from -4 into x star -4 equals to 0 to x star equals to 4?
No, this was just an example.
Now
Yeah.
the top one. If you go up a little bit.
Oh, here.
Yes.
Okay. If you multiply, if you simplify this bracket, you'll say -4 times 4 times x. You'll get -4x, and you'll say -4 times -4. This would be plus 16, right? So this means our f prime at x is -4x plus 16, right? Remember, from here to here, we differentiate. So this means we're differentiating -4x and plus 16. The derivative of a constant is here.
I see.
Right.
Thank you.
Just give me a second. I need to charge. Okay. Can we move on? All right. Our last section is to finding the interval along which the function is increasing or decreasing. Okay. Okay. is to find these parts, this interval, and this interval, and then this interval. Right. Now, suppose you are given a function and you are asked to determine the interval whereby the function is increasing, which is this part and this part, and also the interval whereby your function is decreasing, which is this interval. Okay. Once you know this part and this part, it would be easy to determine that interval. And we said to find this part and this part, we first find the first derivative, we equate to 0. We take that point and substitute back to the original equation to determine the corresponding value of that point. And then to determine whether it is a minimum point or a maximum point, we find the second derivative. Right. Once we know that that point is a minimum or a maximum, we can then determine the interval where the given function is increasing or decreasing. Okay, let's do an example. Suppose we are given a function f at x equals minus x cubed plus 9x squared minus 24 plus 26. Suppose you are given this function and we are asked to determine whereby this function, on the interval whereby this function is increasing or decreasing, right? We said the first part is to find the maximum point on the minimum point. But to find the maximum point and the minimum point, we first has to determine the first derivative, find the first derivative, right? The first derivative of this function, differentiating this function with respect to 0, will give us minus 3x squared plus 18 because we can't have a number in a number. It doesn't make sense. Okay, we have minus 3x squared plus 18x minus 24. Okay, minus 24. We have the first, we have the first derivative. The next part is to equate the first derivative to 0 and let the x there be an x star. So I'll say let f prime at x equals to 0. Meaning we let this to be 0. So we have 3 x star squared plus 18 x star minus 24 equals to 0, right? After equating your first derivative to 0, the next part is to solve for your x star, right? Okay. We have a common factor here of minus 3. We can divide by minus 3. And if you do this, you will find x star squared minus 6 x star plus 8 equals to 0. Okay. You can factorize from here you'll still get the same answer as someone who factorized from here. I was just trying to make this function to be simple for me to factorize. Okay, if you factorize this function, should get x star and x star, and the factors of 8, that will give us 6, 2, because we need -6, so they are both negative. Right, so this means we have x star equals 4, or our x star, okay, this is and x star equals to 2, because this means it's either this is equal to 0 or this is equal to 0, right? And if this is equal to 0, we have x star minus 4 equals to 0. And if you solve for x star here, we'll have x star equals to 4. And this part, if this part is 0, we have x star minus 2 equals to 0. And this will give you x star equals to 2. So this means we have the x value of the stationary point is x star equals to 4 and x star equals to 2. Right. Okay. Then the next part would be to find the corresponding x value. Right. Okay. The corresponding y value. So this means you need to take 4, you substitute back to the original equation, and then you take 2 and substitute back to the original equation and find the corresponding value. But my aim is to find the interval whereby these 2 points are increasing or decreasing. And remember, I said for you to find the interval, okay, it would be easy for you to find the interval whereby these points are increasing whereby this function are increasing or decreasing, once you know which point is the minimum and which point is the maximum point. Remember, we can find the nature of the point without finding its corresponding y value. Right? If you are asked to find points, you need to find that corresponding y value. But in this case, we are asked to find the interval. And we said to find the interval, we need to know which point is the minimum or which point is the maximum point. So there's no need for us in this case to find the corresponding y value, but you can find them as an exercise. But in this case, because I'm trying to save time, I'm not going to find them. Okay, we have 4 and -2, right? Remember, I said to determine the nature of your point, we need to find the second derivative. To find the second derivative, we need to differentiate the first derivative, right? On our first derivative, we said the first derivative is minus 3x squared plus 18x plus 24. So this means we need to differentiate this. To differentiate this, we'll have minus 9x plus 18, right? Okay. This means our second derivative is minus 6x plus 18. Right, we have the second derivative. Remember, for us to know which point is the maximum or the minimum, we need to check the sign of the second derivative. And remember, on our previous example, I said sometimes you'll find your second derivative as a function. You see right now, it is a function, it's not just a constant. So this means we need to substitute our point back here and then calculate. If you find a negative value after substituting your point, then you'll say that point is the minimum point. And if you find the positive value after calculating, you'll say the point is the minimum point. Okay, let's substitute. We have f star star of 4. If you substitute 4 here, we have minus 6 times 4 plus 18. Right? Minus 6 plus 4 times 18 will give us minus 6. Right? And minus 6 is less than 0. Right? And from here, we can say x star equals to 4 is the maximum point. Right? Then we need to find the nature of 2. Okay, we have 2 minus 6 times 2 plus 18. This will give us 6, right? And 6 is greater than 0. Then from here, you can say this is the minimum point. Okay, we have, let's try and draw a rough sketch of this 2 point. We have 4. Okay, we have 2 and 4, right? We said 2 is the minimum point, and we know a minimum point gives the shape, right? And then we said 4 is the maximum point, and we know that a maximum point gives this shape, right? And if we connect these 2 points, we'll have something like this. Okay, this gives this shape, and this gives this shape. Right? So from here, you can say your graph is increasing from 2 to 4, but do not include 2, because you know that here your slope is 0. Here your slope is 0. So you can't really tell whether the graph is okay. The slope is 0, so the graph is not increasing or decreasing because it's changing. So you can write, okay, it's positive here. You can say this function is increasing from, okay, we have 2 and 4, right? To show that you are not including this 2 point, you say you write curly brackets. Right.
Sorry, man.
And then you know that.
Hello? Sorry to stop you, man. Can I ask a question? Where you put I don't know the coordinates for the minimum and the maximum. What are the coordinates for the minimum at 2 and for the maximum at 4? Or you just randomly placed it?
Okay, I know the shape. I didn't put the coordinates. I only put the shape, right? Because the y in this case we don't need them. Okay, maybe the corresponding value here is here, right? Yes. Maybe the corresponding value here is here.
Yes.
It doesn't matter in this case because I only want the shape. Maybe this point, this one is here, and then this one is here. What I know is that this point, the corresponding value of this point is is lesser than the corresponding value compared to the corresponding value of this point. That's why, like this, okay, I decided to put this one here below this one.
Okay.
And
Okay.
I know that for this point to be in a minimum, it has to give this shape. And this point, for it to be a maximum, it has to give this shape. It has to form this shape. And then you connect these two. Okay, remember to give the interval whereby the graph is increasing or decreasing. That interval will be determined by the x values, right? The domain is determined by the x values.
Okay. All right.
Yeah, and these are the x values. And we said these two values, we're not going to include them here because at these 2 points, they are stationary points. So we'll say the graph is increasing between them. And to show that it's increasing between those 2 points, we do not include them, we put the curly brackets.
All right.
Okay. And
All right.
then the graph, all right, no problem. And then the graph is negative here and here. You see, it's from, okay, the numbers are decreasing this side up to negative infinity. We were not told that this function is bounded. If we were told maybe that from this function, x is between 0 and maybe 5, x is between 0 and 5, then we're going to say this function is decreasing from 0 to 2 and decreasing from 4 to 5. But we know like the boundaries of this function were not given. So we just assume that this function is from negative infinity to positive infinity. So this means the graph will decrease from negative infinity to 2. So we'll say decrease from, okay, for negative, for infinity, you always use curly brackets because you are not really sure. Okay, we don't know the value of the infinite. That's why we put curly brackets. So we say decreasing from minus infinity to 2 and from 4 to positive infinity. Remember, 2 and 4, again here, the slope is 0. So we're not going to include them here again. So if you are asked to determine the interval whereby this function is increasing or decreasing, you should have this as your solution. Do we have questions? Okay.
Yes, ma'am, I've got a question.
Yes.
I'm trying to understand why we say it's decreasing when we've noted that it's actually increasing. From 2 to 4, it's increasing, but then why do we say that the points are decreasing?
From 2 to, okay, it's, I didn't say the points are increasing or decreasing. I say the graph will increase from here. Okay, it can start increasing from 2,1, from 2,2, from 3. It can start increasing from from 3.5, but
Yeah.
we know that that point is on this side of 3 or of 2, right? So that's
Yes.
why I'm saying I'm not going to include 2. Because we know here it's 0, it's not increasing, it's not decreasing. That's why we have a curly bracket. But we are not sure whether it starts increasing from 2.1 or it can start increasing from 2.0001. It can start increasing from 2.001, or it can even start increasing from 3. Right, 3.0. But these points, they are included here because they are all greater than 2.
Yeah.
Right, they are all in this side of 2. So that's why we just start from 2, but include 2, we put the curly bracket. Again, it's increased up until before 4. It can increase up to 3. It can increase up to 3.5. It can increase up to 3.8. But we are not sure it's increased up to when. But we know that 4 is not included there. So that's why we just put 4 and put a curly bracket, because we are not really sure of that value, that specific value that's okay, it's increased up to this point. The only thing we know is that 4 is not included in that point, on that interval.
Okay.
I'm not sure whether it makes sense.
Okay, no, I did understand that part. I just didn't understand why you then say it decreases at negative infinity, 2 and 4 infinity.
Wait. Okay. You see here again, I said I'm not going to include these points. That's why I have curly brackets. Okay. I said it's decreased up to before this point. That's what this means. It's decreased up to before this point.
Okay.
Because at this point it's 0. Again, it starts increasing after this point. That's why we have a curly bracket. Okay, this means it's increased after this point, and this means it's decreased up to before this point.
Okay. No, I understand now.
You sure?
Yes, I can see now. I was reading the other way around, but I can see that it is decreasing even after 4.
Okay. You guys. I'm glad it's fine now. Okay. In your spare time, please do work on this. F at x equals x squared minus 18x plus 11, and f at x equals 3x squared minus 0.1 x cubed. These two. Okay. Before we stop here, do we have questions? Can stop recording that recording. Anyone? Okay, I guess you don't have questions. If you guys you don't ask right now, this is my last section with you. And if you send me an email, I might not respond I'll just say forward your email to DSC1520. Yeah. But if you guys you have any question, please do ask the e-tutor under the discussion forum, or please do send your email to Dr. Baba. Or a next lecturer will start with you next week, Monday. Yeah. If you decide to come back, I'll see you next year. But yeah, I wish you guys all the best. The exam is coming. I've set it already. Please do all not just the examples in your tutorial later on your study guide, the examples, and then make sure you do all the assignments. Before the exam, I will release the step-by-step solutions for all our assignments. Okay, I know in our assignment 1, there was some errors. Those questions, I will make them contribute 0. So that's one affects anyone. You'll still get your marks. Because that error was on my side. So even if you see that question there, it won't contribute. I will make it up to 0 before we release the marks. Yeah, but I will release the step-by-step solutions before the end. Before you write your exam. Maybe when you guys will have a revision, yeah, I will release them. But you will go for an exam before you receive those step-by-step solutions. So do those exams, those assignments, and your examples, then you'll be good to go. Yeah.
Excuse me. I
Then
have a question.
Okay.
It's about the 2 questions that you gave us last. Is it 18 minus 18x plus 1 or plus 11? Because there's like a squiggly line next to the 1, so I don't know if that's another 1 or if it's a mistake.
Oh, it's minus 18x plus 11.
Okay, plus 11. Cool. Thank you.
All right. We do have past papers there on model, but my style of setting is completely different compared to those ones on the past paper. So yeah, I suggest you stick on the study guide and the assignments. You can do those past papers as extra exercises, but if you're struggling with them, it's fine. Just make sure you understand the examples, you do the exercises on your study guide, and then you do the assignments. Okay. If we don't have questions, I think we should end here. Okay, again, please do not send me any emails because I might not even respond. I might spend weeks without responding. But do send your email to DSC1520. Maybe I will check those ones, but Dr. Kabam will check, and Prof. Madema Diesel joining us from the 1st of September. She will also check. Yeah. So find a quick response send your email there. If we have issues about the assignments, do not send me any email. Send your email there. Yeah. Thank you guys for your time. You have a lovely evening ahead of you. Bye.
Thank you. That's it.
Thank you, ma'am.
Thank you, ma'am.
Yeah, thank you. Thank you.